Well, hello and welcome to YouTube. Mr. Robbins back here with yet another brand new exciting video, all math-based of course, and as always, it's an honor and privilege to be serving you here today, as there's every day here in my virtual classroom. Okay, step on the side, and we are going to do an overview of everything that we've done in Trig so far. Law of sines, law of cosines, area of triangles, not right triangles, but just triangles using sines. Some practice stuff that we've seen, I think, in the same review fashion as before. The ambiguous case of triangles, whether we can make 1, 2, 3, 0, 1, or 2, I should say, what have you. Oh, look, I have a mark. I've been wearing a hat for the last couple hours today, so apologize for that. Don't worry, you'll see some math, not my forehead. And then we go into some of the trig, converting radians to degrees, degrees to radians, finding coterminal angles of things, actually applying the trig to the unit circle itself, sine, cosine, and tangent, and determining sine, cosine, tangent of any angle given some certain information. I think that's pretty much it, but that's a lot of it. So I think there's 7 problems to start off with when it comes to the overview of the law of sines and cosines, finding parts, doing area, determining triangles, and then 28 problems on trig. Now I got to work within about an hour's time on this stuff. So as I tend to say in some problems like these ones here, I've taught some of the material before, or I've slowed down on some of them. This is how to do these problems, not always just how to teach them. So I'm going to rummage through these problems. It might go a little bit faster. So if you haven't seen this before, either you got to be a fast learner, or you got to check out some of the other videos, or you got to just hear it over and over again with a tutor or something like that. But we're just going to dive straight into it now. Have a calculator handy. At least I'll have mine handy for myself. Okay, excuse me. Solve each triangle. Round your answers to the nearest tenth. So number 1, I'm given a 33 kilometer side, which is technically side C, opposite angle C. I don't know side B or side A. I don't know measure of angle B. Given the information that we have, these two angles, we can find side length A right here, and we can find measure of angle B right now. We can pretty much find all the information right now that we need to, because we can use the law of sines right here. We know the side opposite this angle. We need to find the side opposite that angle. So I can say, for example, A over sine of A equals C over sine of C, like that, for example. If I multiply both sides by sine of 31, I get A equals 33. 33 times sine of 31 over sine of 91. And I'm going to go ahead and calculate that one. I just popped up my calculator here, so let me fire that up right here. Here we go. All right, so I need to make sure I'm in degrees for this one, because we're talking about degree values. And we are going to get 30, that's a 33. 33 times sine of 31 over sine of 91. And this value is for the side length A. This is 16.99, so 17.0 kilometers. Now, as always, I'll use that exact answer if need be for something, but I'll go and change that one to 17 kilometers there. To find B, though, the best approach really is to find measure of angle B. Instead of using law of cosines in these 3, I'm just going to use law of sines again one more time. We're going to be able to use law of cosines later, probably in a different problem. So B, measure of angle B, these 3 add to 180 degrees. So measure of angle B is 180 minus the sum of 91 and 31. 91 plus 31 is 122. 180 minus 122 is 58 degrees. So B is 58 degrees right there. So angle B, we can do the same thing as we did here with A, B over sine of B, etc. So if I multiply both sides by sine of 58, I'll get B equals 33 times the sine of 58 over sine of 91. So the same thing I would have done with A, sine B over sine, like all that kind of stuff, and just set that up. So I'm going to use the calculator really fast. You won't see this, but 33 times sine of 58 over sine of 91. And I'm here getting 27.98, so rounded up is around 28. B is around 28 kilometers right there. So 28. Okay, and that's solving the triangle. We found those 3 missing parts. Let's go to number 2. We're given only 3 side lengths. We don't have any angle measures. This is a job for law of cosines. Law of cosines has one of 2 appearances with them. And it depends on the angle that you're looking for. I'm going to find the measure of angle B right here, because it's the angle opposite the largest side. And if this angle is obtuse, law of cosines will show me that it's an obtuse angle when I use inverse cosine. So I'm going to say the cosine of angle B here equals, and I'm going to say, here's A, here's C. I'm going to say, and here's B. I'm going to say 15 squared, so A squared plus C squared minus b squared. The side opposite is the one that's subtracted, over 2 times a times c, like that. So cosine of b, that's 225 plus 289. This is something I'm gonna let my calculator do this. I don't know 28 squared. 225 plus 289 minus 28 squared. I'm sure I could do it kind of in my head there. So negative 270. Negative 270 divided by 30 times 17, I think, is 510. So negative 270 over 510. Anyway, b is the inverse cosine of this value. I'm sure that fraction can be reduced, at least 27 over 51, if not 9 over 17, I think. Negative. But I'm just going to leave it like that. I don't want to be wrong. Assuming I didn't screw something up yet. So, inverse cosine. Here we go. I'm going to go to my calculator. I'm going to say inverse cosine of negative 270 over 510. And this should give me an obtuse angle here, as I expected. 121.96. So, to the nearest tenth, 122 degrees. So, around 122.0 degrees there for measure of angle B. Okay. So we have measure of angle B at 122.0. Now we got to find either A or C. You can use law of cosines again, this whole setup. I'm just going to go ahead and use law of sines to find one of them. How about A? And then I'll find C by doing 180 minus these two previous values that you had. Now 122.0 was not exact, so I'll make sure to use the one from the calculator here. So I'm going to say sine of A over A equals sine of B over, what's B? 28. So multiply both sides by 15 and take the inverse sine of both sides. So the inverse sine of 15 times sine of 122 over 28. Okay. So that is going to be about, let me just rummage through this through the calculator. Sorry about this. 15 times sine of 122 over 28, and that's all within the inverse sine portion there. 27.02, so around 27 degrees there for A. Okay, now if A is that and B is the other guy, then C is going to be 180 minus those two. So the measure of angle C is 180 minus 122 minus 27, or the sum of 122 plus 27, either or. Now, just looking at them, I should be using exact answers, technically. Oh, you know what? I used 120. I wasn't supposed to use 122. I'm sorry about that. I don't know if it's too soon to recall. I had to use this number here. So I was supposed to use... See? That's why I shouldn't follow what I put in there. Previous answer. It's still going to be around that 27.03. But you can tell it's a different number. 27.02, 27.03. Anyway, both of those are going to add to about your 149. So 180 minus 149 is 31. So measure of angle C is about 31.0 degrees. I think whenever because these problems, I didn't generate the problems, so to speak. I got them to randomly generate, but I chose until I found the right ones to generate. And I think they try and develop answers that even when you round, they're supposed to actually round your integer. So I trust these answers when I'm seeing them here. Plus everything else involved. If we want to do any double checking before I move on, opposite the largest angle should be the largest side, opposite the smallest angle should be the smallest side, etc. 15 is not much smaller than 17, and 27 not much smaller than 31, and I believe the answer's there. And then ranking these in order, 91, opposite that is 33, opposite the 58 is 28, opposite 31, 17. I believe them. All right, number 3. We have this information here, no drawing, and we are going to determine the area of this triangle. So let me give you kind of the idea of this drawing here. If A, not drawn to scale, A is 22 degrees, C is 136 degrees, and B, the side length, has to be opposite angle B, so that's 5. Okay, so we have two angles in the side in between. Immediately, we don't have anything that comes to mind as far as what we can use. Now, as far as area goes, we need two side lengths and an angle in between them. We have two angles in the side in between. If I could find this side length here, then I can use these three to find area. Or if I can find this side length right here, then I can use these three to find area. Don't take these literally as far as these. First of all, this A is for area, not for this A right here. Second of all, it doesn't have to be this A and this B, although it could be. We could literally follow that. We want to go ahead and find this one. In order to find it, though, we need to get more information. I can't use law of sines because I don't know the angle opposite this side, but I can find it. the measure of angle B is 180 minus the sum of 136 and 22. So that's 180 minus 158, so that's 22. So 22 degrees there, and that's exact. Oh, it's isosceles. Take a look at that. So it's an isosceles triangle. Even better. This I don't know, it saves work, but I don't know if you need all the work involved. Anyway, I could use a law of sines, sine of A over A, sine of B over B, like that. But it's an isosceles triangle, and in an isosceles triangle right here, opposite sides are congruent. So if this is 5, so is that. That's as fast as it gets for me, and I'm just going to go ahead and use that one, take advantage of what you have. But I would have used law of sines to solve for that. Since we're not getting into any other triangles and solving things, and I said I'd use law of cosines later, which I did. I used it for this instance here. Let me throw out another equation just so you know what this is unrelated to this problem. I really apologize. But there's another equation for law of cosines which looks like this that could be of use. And this one's used whenever you're trying to find a side length opposite two known angles and the side in between. For example, if I wanted to find side length C, you know what? Let's find side length C just to have it. If I wanted to find side length C, I know these two sides and the angle in between. So I could say this C is C squared equals A squared plus B squared minus 2AB times cosine of C, like that. Now I could also use law of sines to find it, right? I could have done A over sine A equals C over sine C, like that. But just to kind of show you this one, 50 minus 50. C squared is 0? That doesn't make any sense. Oh, no. Yeah, 50 minus 50. That doesn't make sense. Oh, cosine of 136. I'm sorry. I wasn't paying attention. C squared is, sorry about that, 50 minus 50 times cosine of 136. I was like, hold on, something's wrong. All right, 50 minus 50 times cosine of 136. 85.9, so like 86. C squared's around 86. Take the square root of both sides, and you get C is about, it's going to be a little more than 9. Obviously doing this worksheet on the fly, 9.27. So C is around 9.3 units. So clearly as that's the rounded value, I don't really want to use that one. To do area, I'm just going to go ahead and use these three right here. The same 1/2 AB times sine of C. So the area, I don't know what that was. The area is 1/2 AB times sine of C. Like that. So half of 25, 12.5 times sine of 136. All right, I'm going to do that in the calculator here. 12 point sine 136, and I'm getting 8.68, so 8.7 square units right there. That is the area of this triangle, so it's going to be C right there to make sure it's not any of the others. 8's pretty close, but that's it. Okay, I'm going to move forward, and I have 4 problems here. We're going to state the possible number of triangles that can be formed. So first, we're going to start with an acute angle measure B at 63 degrees. That's more acute than it should be. The side opposite B is 31, and the side connecting it here is 9 as far as miles go. Doesn't matter if this is acute or obtuse, as long as the side opposite is larger than the angle that we know is larger than a side that makes the angle right here, only one triangle can be formed. Absolutely one triangle can be formed, and only one triangle can be formed. See, I can extend this side as long as I want and fix this angle as much as I want, and it connects here. This is just one triangle because this 31 is greater than 9. The one opposite the angle, 31 is greater than 9. One triangle. And again, if you haven't seen me do this stuff before, it's something that you want to probably dig deeper into. Find the work that I did on, I think it's under the law of sines. I forget if that's what it's called, but it's the sines video that I've done recently. All right, number 5, this is an obtuse angle, and this is once again one of those instances where as long as the side opposite is larger than the side that makes to connect the angle, then you're good for one triangle. Now this B, if I made 30 miles here, the C is 22 miles. On the other hand, if it's equal to or shorter than that side length, 22 ain't enough to go back and reach this right here. It's not enough to go and reach this side. No matter how much you want to rotate this angle, it don't connect back. Once this angle is obtuse or a right angle, it's not enough. Not enough. It needs to be longer than to make that one triangle. You can't make any triangles here because the 22 is less than that 30. No triangles. Okay. All right, two more. I got an acute angle here at 71 degrees and measure of angle A. The side length A is going to be opposite. That's 14 centimeters right here, and this C is 23 centimeters. Now, unlike the last problem where the angle was obtuse and it didn't have enough to reach back, this one may be a little bit different. Because it's an acute angle, this thing gets to bend inward toward the triangle more so that maybe 14 is enough to actually bend in and reach and go, can I reach you? Can I reach you? Can I reach you? Can it actually touch that side? I don't know the answer. What I do know is we can calculate it by saying, what is the shortest side length possible that can reach here? The shortest side length is the one that would go perpendicularly into it like that. Some h value, this h. And in this right triangle, I can determine this h value right here by using sine. The sine of 71 is h over 23. So h is sine 23 times the sine of 71. If this value is more than 14, if it's more than 14, sorry, if 14 is less than that value, then 14 is not long enough to even reach the shortest length I can make. If 14 is longer than it, then you can reach, and we'll talk about that. But let's check that out in the calculator here. Let's do 23 times sine, I missed it, 71. 23 times sine of 71. And it's 21.7. Okay, that's much bigger. So around 21.7 centimeters. That's bigger than 14. 14's not long enough to reach that side. It would be scraping like swinging right here and trying to reach it. Can't reach it. So 21.7 being greater than that 14 means no triangles are possible. Right here, no triangles, triangles. Okay, in this last scenario, we have an acute angle at 37 degrees on A. The side opposite A being 21 miles. The C is 30 miles right here. 21's less than 30, so not one triangle guaranteed here. The question is 21 long enough to be able to connect into this side and reach and whatever? So let's look into that height again. Let's see how long that height will be. Sine of 37 is h over 30. So h is 30 times the sine of 37. Without having you peek too much in the calculator here. 30 times sine of 37. This is it's 18.05, so around 18.1. 18.1 miles. If this is 18.1 miles, the shortest possible length, 18.1 miles, then that means that 21 is enough to reach. It won't reach straight down. It'll actually reach right here. Here's 21 miles right there. Yeah, I can make a triangle that looks like that. Or it can swing over here and I can make one that looks like that. And when I'm talking about these triangles, I mean, look at this one in red. There's a possible triangle with 21 right there. Or look at this one in green. There's a possible triangle, 21 there. This angle side-side situation does not guarantee, not even one triangle, but it's not a unique triangle in these situations. And this is one where that 21 is longer than the altitude, the shortest possible length, and not quite as long as the 30 that would make the triangle isosceles, or more so, just like more like more obtuse, so that it only makes one triangle. This can make two. This can make two triangles here, as it's within the length of the altitude and the side making the angle. Okay, and that is it on this law of sine stuff. The rest is kind of it's all trig, but the rest is unit circle. Ooh, did I not import this? Give me one moment and pause it and put these in. And we are back. Okay, I got it in. So, the rest of the way, 28 more problems to do here, but they should go a lot faster. And again, I'm going to talk through how I go about it, so have fun with it. And I'm going to avoid calculator whenever I can. Anything I don't have to use a calculator for, I'm not going to. All right, convert each degree measure into radians and each radian measure into degrees. Negative pi over 4, so it's going to be a negative degree answer. Pi is 180, so that's negative 180 over 4, or negative 45. Here on out, anytime you hear pi over 4, I'm going to call it 45. That's something we're going to have to know and turn into. 210. Now, 210 is actually a special angle, and if you've worked on the unit circle, then you know that it is one of them. You know, it's from 0, it goes 30, 45, 60, 90, 120, 135, 150, 180, 210. 225, 240, 270, 300, 315, 330, 360, and so on and so forth. 210 is one of the special angles. It's 30 degrees away from 180 degrees right there, right? 30 degrees down, something we'll talk about later. But 210 is a multiple of 30, and that's important as far as you might know that 30 degrees is pi over 6 radians. So 210 is 7 times larger than 30, so it's 7 times pi over 6. 210 is 7 pi over 6s. It's 7 pi over 6. That's the quick transition. Now 660, I couldn't tell you off the bat whether it was a special angle other than telling you that I know for sure it's a multiple of 60. 660 is 11 60s, negative 11 times 60, or negative 11 times pi over 3, as 60 degrees is pi over 3 radians. So that's negative 11 pi over 3. That's my immediate jump into that. If this fraction could reduce, I would do that. And I might call attention to one of those at some point if I need to, because I might not know. Maybe this was a multiple of 90, and I wouldn't have known until I reduced the fraction if I had to. But there's the answer. Okay, negative 9 pi over 2. We are once again in negative territory. Just get used to the facts. A couple of negatives here. Pi over 2 is 90 degrees. So we're doing negative 9 times 90. That's negative 810 degrees. Boom, straight up. 11 pi over 9, although this is not of our special triangles, pi is 180 degrees. So this is like 11 times 180 over 9. Now, before you get your calculators out too fast, please understand you do not have to multiply 11 with 180 first. Notice how I haven't been kind of working things that way with pi in the past. I wasn't calling 11 pi over 3, before it was 11 pi over 3s, right? So this is more like 11 pi over 9s. It's 11 180 over 9s. Let's divide those first. 180 over 9 is 20, and 11 times 20 is 220. Right? That's kind of the faster way to go about that. There are a lot of other little, I'm not going to say tips and tricks, but for me, knowing this should be my answer, not should be my answer, but I know my answer should be more than 180. Because pi is 180, and 11 ninths is more than 1. So this should be more than 1 times 180 there. Okay, 65 degrees. Definitely not a special angle here. And this one we have to convert to radians. The general conversion is multiplying by pi over 180. Turn whatever was 180 times smaller, replace it with pi, which is what I'll do. But I'm going to work on reducing that fraction more so. It's more like 65 over 180 and place a pi in there. So reducing 65, honestly, I don't know. I'm going to divide them by 5 first. Because it divides 5 times 13. So this is 13 pi over 180 is 36. And that's I think that's as small as it goes, 13 pi over 36. But you reduce the fraction, right? That's what you work on. Negative 7 pi over 12. Again, pi over 12 is not a special angle. Well, first of all, the answer is negative. So this is negative 7 times pi over 12, 180 over 12. Which is, I should know that, I do, 15? 15. So negative 7 times 15. I should know 7 times 15. 105. So negative 105. Should be around half of 180, which is 90. Just a little more or less since it's negative. And finally, 200. That is, wasn't answer 200 before? No. Finally, 200 degrees. That's, again, what is 200 180ths times pi? Divide those by 20, you get 10 ninths. It's 10 ninths pi, 10 pi over 9 right there. So just kind of working that out, reducing the fraction, what's there. You are multiplying by pi over 180, but I'm really seeing 200 out of 180 as what fraction of pi? What fraction of pi? Okay, find a positive, negative coterminal angle for each given angle in the units given. That part's my typing, so having given twice is, I don't like that. All right, 160. We can find a positive coterminal angle by adding 360 to 160. Coterminal angles are a full revolution around. You could add another 360 to make 720, to add 1080, to add 1440, add 1800. You can keep adding things at 360, but you just need to find a single one. This one's 520 degrees. It is coterminal with 160. A negative version of this is subtracting 360 from here. So when they said in the units given, keep these in degrees as we started in degrees, and that's going to be negative 200. When we do the radians right here, we are going to add 2 pi. Whoops. Well, yeah, we're going to add and subtract 2 pi from here. Now, 2 pi You want to keep this as radians. You want to keep it as the same fraction bit. So I'm going to multiply top and bottom by 4 here to make it 8 pi over 4. So I'm going to add 8 pi over 4 for the positive coterminal angle. So 5 pi over 4 plus 8 pi over 4, which is 13 pi over 4. That's the positive coterminal angle. And then I'm going to subtract a 2 pi or subtract 8 pi over 4 to get negative 3 pi over 4. And that's my negative coterminal angle in radians right there. Okay, that's it there. All right, the next several problems, I think it's like 12 of them. And this is really the important aspect of this, not just for now, but going later. Find the exact value of each trigonometric function. So numbers 11 and 12 are graphed to your benefit here, I suppose. 13 pi over 3, there's a coterminal angle of this. These are a bunch of pi over 3s. If you want the degree version of this, just converting, that's 13 pi over 3s, 1360s, 780 degrees. If you were curious what 780 is, and you can see the revolutions, that's a full 360, plus another full 360, which is 720. Now, 780 is 60 more away from 720. So what's important for us is the reference angle of 60 degrees up from the x-axis. And that's exactly what this is. Hang on, I have a very important email I have to take a look at that just popped up. Okay, I'm back, sorry. All right, so 780 degrees, and you didn't have to do that. You probably want to. I'm going to focus on these in terms of degrees. I will convert them to degrees as far as the reference angle, because I like to talk about it as a 30, 60, 90 right triangle, not a pi over 3, pi over 6, pi over 2 right triangle. You know what I mean? But getting it in here is a 60-degree reference angle. We are in the first quadrant. My ratio relationship that I build, if you haven't seen my videos, is 1 to root 3. 1 to 2 to root 3 relationship. Opposite the 30 is the shortest side. Opposite the 60 is root 3 times larger. Opposite the right angle of the hypotenuse is twice as large. Now, these are all positive because we're in the first quadrant. We have to take the cosine of this. Cosine of our theta, cosine of 13 pi over 3, which is apparently coterminal with pi over 3. That is going to be adjacent over hypotenuse. That is 1/2 right there. These will go faster. 8 pi over 3. We're going a full, again, this is 8/60s, so 480 degrees. Now it's drawn, but as I'm going to draw some for you later, I want to make sure that you know what this looks like. So it's a full 360 plus another 120 degrees right there. And 120 degrees is but 60 degrees from 180. So when I draw my reference angle to the x-axis here, I got another 30, 60, 90 triangle right there. I have another 1 to 2 to root 3 relationship. However, this time, the 1 going to the left on the x-axis is negative. Now, we're going to be taking sine of this. As the root 3 goes up, it's still positive, and sine of this is opposite that 60, so it's root 3 over hypotenuse 2. So sine of 8 pi over 3 is root 3 over 2. And I haven't yet preached for my students to do this mentally. I think by next unit for some of them, I will challenge them to do so. Because this is something I picture the drawing in my head. But as far as whatever time you can save and not doing the drawing and stuff is totally your call. But I'll keep drawing some for you. I might say some out loud and then go back to the drawing. Tangent of 45 degrees right here. 45 degrees is, of course, 45 up from 0 degrees right there. And this is a 45, 45, 90 triangle relationship, which is 1 to 1 to root 2. Tangent is opposite over adjacent. And when I talk about these, I'm referring to SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's 1 over 1, better written as 1. Sine of 210 degrees. 210, and I think we spoke on this before, it's 30 degrees down from 180 right there. And when I say down, I don't mean less. I mean physically, visually, it's down right there. So that's the 30-degree reference angle. 30, 60, 90, we have the 1 to 2 to root 3 relationship, but the 1 and the root 3 are negative. That is a negative root 3, by the way. But the sine, the hypotenuse is always positive. The ones that go left and down, though, can be negative. So sine of this thing is opposite negative 1 over hypotenuse 2, negative 1/2. So far, no denominators have yet to be rationalized. I kind of hope we run into some soon. All right, cosine of negative 270 degrees. For one, it's negative, which means we'll be going clockwise. For another, 270 is a multiple of 90. It's a quadrantal angle. 90, 180, 270. Now, cosine of negative 270 is the same as cosine of 90. I just want to make sure that you understand that it's the same as going just this way, 90 degrees. We're ending right here. Now, as far as my drawings go, if you've seen my stuff on this, how I talk about this is pretend like you have a right triangle that squished itself to the 90 degrees, literally to up there, but I'm giving yourself a little bit of a triangle so we can talk about what the adjacent, opposite, and hypotenuse are. If your hypotenuse was 1, as a unit circle would be, the adjacent side would squish to 0, to nothingness, because we're on 90. Triangle is squished. And the opposite side matches the hypotenuse as 1, because they become one the same thing. It squishes into the same thing. So if this is 1, so is that. 1, 1, 0. Cosine of that angle is adjacent, 0, over hypotenuse, 1. 0 over 1, which is 0. Another way to know it is, on your unit circle, all the ordered pairs on the unit circle are some x, y value, right? And on the unit circle, we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. It is established that your points on the unit circle are found by taking the cosine of your angle of rotation and the sine of your angle of rotation as the x and y coordinates respectively. My point being, if we landed on 90 degrees, the x value of this is also the cosine of that angle. It's 0. It's 0. So I'll point to that one first the next time we run in a quadrantal angle if we do. Tangent's a little different because tangent is sine over cosine, and you might not know that yet. So that one's a little tougher. That's why you might want to still refer to that. All right. Tangent, well, you might know that. My students probably don't. Tangent of negative 120 degrees. So negative 120, once again, is clockwise. 120 is 30 away from 90 right here, which is 60 away from the 180. But we're 60 down because we went clockwise. So this is negative root 3 opposite the 60 and negative 1 and 2. Tangent is opposite over adjacent. So it's negative root 3 over negative 1, which is positive root 3. Tangent of negative 120 is positive root 3. Still with me? Cosine of negative 3, I have to use the parentheses, I feel like. Cosine of negative 3 pi over 4, that's the same thing as cosine of negative 3/45 or cosine of negative 135. And if you want to convert first, that's great. Otherwise, just do your pi over 4. So we get 1 pi over 4, 2 pi over 4, 3 pi over 4. Point being, what's the reference angle? What's the quadrant? We go 135 degrees this way to be 45 below 180. We're in the third quadrant again. 45, 45, 90 triangle, 1, 1 to root 2, both of those being negative as we go left. Cosine is adjacent over hypotenuse. So that's going to be negative 1 over root 2. And you would be done, but here's our first denominator that needs to be rationalized. We got to multiply top and bottom by root 2 right there, and we will get negative root 2 over 2. That's the general thing. Sine and cosine have that root 2 kind of bit going. Okay, sine of pi over 2. That's the same as sine of 90 degrees. Now, I made mention, I stated that I would refer to this one again if you want to see it. The y values of your ordered pairs all around the unit circle are same as the sine of your angle of rotation. And so if we're at 0, 1 right here, 90 degrees up, then the sine of pi over 2 is actually going to be 1. It's actually going to be 1. And if you're uncertain, refer to this unit circle right here again, the reference angle thing we built before. The sine of this is opposite over hypotenuse, 1 over 1, which is 1. Sine of negative 495 degrees. Okay, I don't know that 135. It's coterminal with negative 135 apparently, because what this one is right here, you'd have to go, it's clockwise by the way, 360. How far away is 495 from 360? It's another 135 away. We've seen this before. I think we did cosine at the time though. We've seen this before, so it's right there. So it's coterminal with the negative 135 or coterminal with positive 225. So this is a 45 degree reference angle. So once again, that relationship. Looks like we're getting some of the similar ones. But sine of this is negative 1 over root 2, which again is negative root 2 over 2. So same answer as cosine because it's in the same area for different reason. And it's sine. Okay, tangent of 570. Now 570 is a 360 plus a 210. So it's the same, just to let you know, it's the same as tangent of 210 because that's coterminal with it. If you need to draw that out, that's a full 360 plus another 180 is 540 plus another 30 is 570. So 210 degrees is 30 degrees down from 180. Should have probably drawn it more that way. Once again in the third quadrant. Man, these problems did not stop from being in the third quadrant, and I think this one is too. Excuse me. So this is -1, -√3, and 2. Sorry for not having any fourth quadrant, it seems. Tangent of this is opposite over adjacent, so this is -1 over -√3, which is +1 over +√3. But we must rationalize the denominator. That's going to get you √3 over 3. And you would have seen, you know, not if you're new to this, but if you're really seeing a lot of them for the first time, a smattering of these problems, you're probably saying, I've seen a lot of these ratios before. This is the first time we saw √3 over 3 together. But, you know, you're also saying, you might have seen this before, but you're seeing, I've seen √2 over 2 before. I've seen 1/2 before. So you'll have seen these before. There aren't too many different ways you can do these ratios, you know. All right, tangent of -270 degrees. Once again, I can't seem to stop from making this go to certain exact things. -270 is clockwise, 3/4 turns, and it lands you on 90 again. Now, tangent does not happen to be one of the ordered pairs here. The x is cosine of your angle. The y is sine of your angle. Tangent does, this is something you might learn later down the line, but tangent of an angle does happen to be the sine of an angle over cosine of that angle. So you could do this 1 over 0 like that, but I'm going to show it based on the drawing that we did before, and I'll do the same kind of drawing. So this drawing, let's squish a right triangle so that the adjacent is 0, the opposite is 1, as the hypotenuse is 1. Tangent is opposite over adjacent, that's 1 over 0. 1 over 0 is not 0, it is undefined. So that is an undefined value. There's not a defined value at 90 at pi over 2 for tangent. If it was on a 180 like this, it would be 0 over 1. Opposite would be 0, adjacent would be 1, which is 0, but it wasn't. All right, and cosine of -4 pi over 3. Again, I feel like I've already seen this one, but we are clockwise. We are going, 4 pi over 3 is, oh, I'm sorry, 4 pi over 3, not 2 pi over 3. I don't know if we have done this one, but 4 pi over 3 is 240 degrees. So it's up here, 60 away from 180. Well, we might have done this one. -1 opposite the 30, the positive √3 and 2. Yeah, cosine is -1 over 2. That's -1/2. And maybe we did do that one. Okay. 6 more problems. 6 more problems and then we are done. Use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated, cosine of theta. So theta is your rotation here. I don't know what the actual angle is. We could use calculator stuff, figure it out. That's not the point of what we're going to do. We're going to find the actual exact answer how we can based on the values. This is an x value and a y value. This isn't even a unit circle anymore. It's maybe from a circle, but a unit circle indicates a circle of radius 1. This circle doesn't have radius 1. I know that because this length is 10 and this length is 15, as indicated by 10 and 15, the ordered pair. And that's a right angle, and this hypotenuse would not be 1. That wouldn't make any sense. How would I find that hypotenuse? First question is, do I need it? Yeah, because in this reference angle here, if I want to do cosine, I want to do adjacent over hypotenuse. I need this x. It's basically going to be 10 over x. And whatever x is will be the hypotenuse for the answer. So I will use Pythagorean theorem to find that out. 10 squared plus 15 squared equals x squared. So I'll get x squared equals 325. So x is the square root of 325. Now it's not calculator time for this. What it's time for is simplifying the radical. I don't know larger exact perfect squares other than 25 to start. So I'm going to start with that. 25 times, what's $3 and go to 12, 13? Okay, so that's going to work. So that's 5 root 13. So as an exact value, it's 5 root 13. I should have saved this 23 for, I should have swapped the problems. 24 should have gone first. So the cosine of that angle then is adjacent. See, I don't know the actual angle, but it's adjacent 10 over hypotenuse 5 root 13. This is some form of an exact answer. It's the exact value, but it's not reduced and simplified. 10 over 5 can reduce to 2 over 1, so it's 2 over root 13. And now I have to rationalize it. I multiply top and bottom by root 13, which becomes 2 root 13 over 13. And if 2 over 13 could reduce, I would go ahead and do that, but I can't. So there's our exact value right there for cosine of whatever that angle is. I used Pythagorean theorem to find the side because I needed to, because adjacent over hypotenuse. Okay, and this one right here, same thing. We're going to go for... Oh, my mouse glitched out. Oh, here it is. There it is. Okay. I think my software thing glitched out. We're going to go 4 over, like that, and then 2 root 5 down, like that. And we need tangent of this angle right here. So tangent is opposite over adjacent. That's why I'm saying we should have started on this problem. I don't even need this value for Pythagorean theorem wise. I just need opposite over adjacent. The other thing about this problem is I don't need to rationalize the denominator. Opposite over adjacent. Negative 2/4 can reduce to negative 1/2, so it's negative root 5 over 2. And that's my answer. But yeah, that was an easier problem than the first one. So in the first one, again, we needed hypotenuse because cosine needs hypotenuse. And these are the lengths of those values. And we don't need the angle, we just need the ratio for the angle. And we had to simplify the radical and things like that. All right, last 4 problems, kind of the same ilk, but in different methods. And here's where I'm actually going to use the calculator in these problems 25 and 26. Not 27 and 28. So in 25 and 26, what I'm going to do is determine what this... Ooh, this is glitching. What I'm going to do is determine what this actual angle is to start with, but I also want to determine what quadrant we're in. So we need to, what do we need to do? Find the exact values of the basic trig functions, trig ratios not given. So we're given what cosine is. We have to figure out what sine of our angle is and what tangent of our angle is. In order to do this, let's find out what the actual angle measure is here. I'll use the calculator for that by doing inverse cosine. Theta is inverse cosine. And to be fair, I don't actually need to know what the value is. I just need to be able to calculate what the value is. It's this. I need to be in degrees and all that. But the other aspect of this is you do want to know what quadrant you're in because you want to know what the signs of these are going to be. The ratios are going to be the same whether it's in one quadrant or the other, but it's either positive or negative, and you want to know. How do you find out? Cosine's a positive value because it doesn't show negative. And they say the sine value is also going to be positive. That's the greater than 0. The only quadrant where cosine and sine are both positive together is the first quadrant. So we're in the first quadrant. Now, I'll show you that reference angle with the calculator right here, but for the most part, I'm not going to use it, except I'm going to use it, but I'm just going to use the exact value. So the inverse cosine of 0.638 is 50.357 degrees. I'll just say around 50 degrees, so whatever. It's around 50 degrees. The point being, what you're going to be doing is you're going to be taking the sine of 50 and the tangent of 50 in the first quadrant. So your answer should be positive. We know our answer should be positive, and not exactly 50. I'm going to take sine and tangent of this value that I just saw here. So if you want to do exact and you can't recall previous answer, you can actually type in what that previous one was like that if you ever wanted to. So sine of the value, sine of 50-ish, is going to be 0.770. I'll do 3 decimal places. And the tangent, let's recall that same thing I just called tangent. The tangent of that exact angle is 1.207. So I'm going to write for sine 0.770, and for tangent, these are approximate, 1.207. And they are positive because we are first quadrant on that. Okay, this time we're going to be given tangent, and they're going to tell you that we are between 90 and 180 degrees. Pi over 2 is 90. This is 180. So this time they're giving you the domain of this reference angle. We're in the second quadrant right here. And it makes sense that tangent's negative. It's a courtesy that they're telling you it's negative to confirm that you're in a quadrant that it should be negative. But I'll tell you what, it can serve as a detriment to you as well if you take the inverse tangent of the negative value. I'm going to do the positive one because all I care about is the reference angle. I don't want to know what the sine and stuff of it is. And in fact, it's just going to give you a negative value that's not in the second quadrant. And then you're going to trust the signs of what we take. Just do inverse tangent of 1.237 to get what the reference angle is, how large this is right here. That's all we care about. And again, do I care about the exact, actual angle? No, but I think tangibly you might want to see what this thing looks like as far as it. It's 51.04, so around 50 degrees again. So it's around 51. Point being, I care about what sine and cosine is of this, knowing that my sine answer should be positive, because sine in second quadrant, sine is positive. All students take calculus. Sine is positive in the second quadrant. Cosine will be a negative answer. So when I use my calculator, I'm going to take sine and cosine of 51, or this number, and I'll just know that I want to put my sine answer as a positive answer, and I'm going to put my cosine answer as a negative answer. That's your best bet on going about these problems. Not inverse tangent of the negative, because it'll just give you a negative value, and guess what? It'll actually flip sine and cosine values. You don't want to do that. So let me just do this straight up. Sorry. Sine of that value here is 0.777669. So 0.778 to 3 decimal places there. Cosine, remember, make this answer negative. Hold on. I need to recall that value. Give me one sec. I probably should have just typed it out. Cosine of that is negative 0.6. Now, it says positive on my calculator. I need to recall here. It says positive on my calculator because I'm just looking at reference angle only. I'm making it negative. So it's going to be negative 0.629. Negative 0.629, like so. Okay, last two problems here. These ones fall probably a little more in line with what you saw here. The difference is here we're getting an actual ordered pair. This time we're given a ratio and we got to kind of build the values that we have in the triangle. Now we also need to know what quadrant we're in. Sine is negative 5 over 13. Now there are two different quadrants where sine would have negative 5 over 13. And they would be like right here, negative 5 over 13, and right here, negative 5 over 13. The question is, which quadrant are we in? And it's important because I'm going to take cosine and tangent of my angle, and depending on which of these quadrants I'm in, tangent's positive here, cosine's negative here, and cosine's positive here, tangent's negative here. How do I know which quadrant I'm in? This information here tells you that we need the cosine to be positive. So what quadrant has sine negative and cosine positive? Quadrant 4. So we're going to be in quadrant 4 for this one right here. We are going to not be in quadrant 3. So let me rebuild that right now. I mean, quadrant 4, I know that my opposite is negative 5, my hypotenuse is 13. How do I know this is negative and this one's positive? Because I'm going down and hypotenuse is always positive. And because they tell us it's positive here. So we still need to find this value here because both cosine and tangent use adjacent. So Pythagorean theorem would be x squared plus 5 squared equals 13 squared. I can tell you right now it's going to be 12. This is a Pythagorean triple. X squared plus 25 is 169. X squared is 144. Take the square root of both sides. X is 12. By the way, you have to remember when this is supposed to be positive or negative. 12 is going to the right. That's another reason we got to draw this. 12 is going to the right, so 12 is positive right here. So when we do cosine of this thing, I'm not using a calculator for these. I'm just doing adjacent over hypotenuse. I get 12 over 13 positive, as it should have been. And tangent in the fourth quadrant is negative, as we do opposite over adjacent, negative 5 over 12. Those are exact. We're good. So the only time I use the calculator, unless I forget, I use the calculator in the first pages. But the only time I used the calculator for the trig stuff was literally 25 and 26. All right, let's see if this one gets tricky. 5 pi over 6, and we're between 180 and 270. So we're in the third quadrant here, quadrant 3. So we know that we're in quadrant 3. Tangent is positive as expected there. 5 root 6 over 12. That's opposite over adjacent. Now, the important thing to remember is the 5 root 6 and the 12 are negative. We're going down and we're going left. Why does that make tangent positive? Because a negative over a negative is positive. I think we actually saw a couple of those. Now, sine and cosine both use hypotenuse, so we still have to find that. Let's use Pythagorean theorem to determine those. So 5 root 6 squared plus 12 squared equals x squared. Now, I don't know this value. 5 squared is 25 times root 6 squared is 6 plus 144. 25 times 6 is 150. And that's 294. That's not a great value. And I can't divide it by, oh gosh, I might have to use a calculator. All right, well, I'm just calculating to see what I can divide by. I'm trying to divide by perfect squares. It can't divide by 4, I can say that much. And if it can't divide by 4, then it can't divide by 16. Let's try and divide it by... It can't divide by 9. Let's try and divide it by, not 25, let's try 36. What did I just do? 294 divided by 36. I don't think so. Let's try 49. I'll have no idea. Yes. Okay. So what I did there, I was finding... that number's a little large for you guys to have to do. So I was finding a perfect square factor. The reason I said my numbers, I said 4, 9, 16, 25, 36, 49. That's 2 squared, 3 squared, 4 squared. I want to find one I can divide out. And I didn't know. I wasn't going to play with that too long. So that's 7 root 6. Okay. So x is 7 root 6. This is a good last problem to have here. Okay, so we got to do sine of this and cosine of this. Sine of this angle is going to be opposite over hypotenuse. This is nice because the root 6's go away and you're left with negative 5/7. And it should be negative. It should be negative. And same with cosine, should also be negative. But this one is negative 12 over 7 root 6, and that's not rational. Now, I don't know how often you guys have rationalized denominators that have a little extra stuff in front. We don't have to multiply top and bottom by 7 root 6 over 7 root 6, just root 6 over root 6 like that. And that becomes negative 12 root 6 over 7 times 6. Now, before you get too caught up in multiplying 7 times 6, notice I can divide 12 and 6. 12 divided by 6 is 2. So this becomes negative 2 root 6 over 7. That is the simplified version. Oh, you can't see that. That's a simplified version of that answer there. And that is it. All right, guys. I think I just lowered my mic. I'm sorry. I don't know if this is too loud or not anymore. Sorry if this is too loud. Okay. And that is it. Okay, so guys, this is Mr. Robinson. Thank you so much for watching. I know I went a little fast, but this is based on stuff that you may have already learned in the past. Nice little drill and kill. That's all I have time for. That'll do it for this one. This is Mr. Robinson. Thank you so much for watching. Take care. See you in the next one.